Hello everyone, I'm going to introduce my work on distributed learning networks for medical imaging today. I found this idea very interesting when I saw the Google Federated TensorFlow Federated platform that was just published, and I looked for papers and research online. I found a paper that introduced this idea and did experiments in detail. So I thought maybe I could reproduce this paper, the model, algorithm, and the results. So what is distributed learning? In large-scale machine learning projects, especially in healthcare area, sometimes it's hard to collect data from separate institutions because of a legal issue, a privacy issue. So researchers are looking for another approach to replace the traditional data centralized training, which is distributed training, where there are separate institutions. For example, in this experiment, we have four clients. Each institution has their own data set. They don't have to share and they don't have to give the data. The server has a model and the server distribute the model to the four institutions, and each one train the model on their own data set, and they just need to give the server the weights of after the trained model, and the server will average the weights from each institution and transform the updated weights to them again. So that is the next iteration of the distributed learning. This approach is also referred as distributed averaging. So in this work, I used retina dataset, the medical imaging classification tasks, and the general approach, the traditional approach is CNN, which uses ResNet34. In real world, we can ensure that each institution, for example, hospital, have the similar size of dataset or similar quality of images. So I explore the image quality variability here and the class imbalance variability. For example, healthy cases are much more than the unhealthy cases. So here are the results. I used two approaches to solve this problem. The first one is to skip the variable institution. The second one is to add a weighted averaging during the distributed learning. All of them can mitigate the loss from the variability, but the weighted averaging is more effective and reasonable than the skipping approach. So in future work, I may further study the details of the weighted averaging approach.